And hence let us try to understand how program memory is organized for the PIC microcontroller. You recall how much program memory we have got for the PIC microcontroller. In the features we say it is 8 kilobytes, 8k into 14 is the program memory available. Now how you can access that program memory? So basically there is one register called as program counter register. So that program counter register is a 13-bit wide register. 13 bits are sufficient to address 8k locations. So this PC can be used to access any of the location available in the program memory. So program memory addresses are starting from 0000H up to 1FFFH. So these addresses are again divided into 4 pages, page 0, page 1, page 2 and page 3. So paging is done here, and then you find that some addresses are very specific addresses, like address 0000. So this is what? This is a reset vector address. Whenever you apply some reset signal to the microcontroller, so the instruction which gets executed, which is stored at this particular address. As well, you have got one special address location called as 0004H. What you got here is an interrupt vector. As we know, there are many interrupts. Around 14 different interrupts are there for the PIC microcontroller. And you find that all these interrupts are vectored interrupts. Whenever interrupt occurs, the program execution sequence changes to this particular address 0004. It will be very interesting to know if all interrupts are occurring and interrupt vector address is same, then how microcontroller will understand which is the cause of that particular interrupt. Now talking about the additional facility in the microcontroller along with the program memory and data memory is stack. So you have got 8 level stack available inside the PIC microcontroller. It is not part of program memory, nor neither program memory nor data memory. It is a separate hardware stack available. And then you have got 4 pages, each page is of 2k, so 8k memory is there. Now look at how stack operates. So you said 8 level stack is available. See, stack operates, stack basically is used for what? Whenever you are executing some call instruction or some interrupt occurs, after execution of interrupt service routine or any subroutine, you want to come back to the main program. So how it is possible? You can come back to the main program if and only if the PC contents are stored somewhere. So we use stack for storing the contents of the PC. So when call gets executed or at the end of subroutine when you write a return, so this stack is used. Now one important thing, only 8 stack locations are there inside the PIC microcontroller. So if you can push for 8 times only. If you try to push 9, means if you try to have 9 successive calls, what it does is that 9 push overrides the value that was stored from the first push. So if you are going just writing call instructions and they are storing the contents of PC, so 8 pushes are possible. But if you go for 9, so then that first push address will be overloaded by this push 9. So you cannot come back to the main program in this particular case. This you have to remember. So it's like cyclic buffer. Stack basically, this for PIC microcontroller acts like cyclic buffer. So as such, there is no status bit which will inform you that stack is overflow. So you have to make sure that that stack overflow is not occurring because of your program. As well, there are no instructions like push and pop. So you cannot access stack from any instruction. Only that call and return instruction, as well that return from interrupt. So these are the instructions which can only result into usage of stack, either for storing some data onto the stack memory or retrieving the data from the stack memory. Basically it will be an address and that will be contents of PC.